Welcome to the class, student. We'll continue the chapter surface chemistry, and now you have to do colloidal state. And Thomas Graham, this name of the scientist you have to remember. He classified the substances which are soluble in water form solution into two forms, as you can see, crystalloids and colloids. You should know the difference between crystalloids and colloids. Crystalloids, when the substances dissolve in a solution in solvent, then they can be converted or can be obtained in the crystalline form. And if you filter them, they will pass through animal membrane. Nothing can be left over on the membrane. The whole solution will pass across the membrane. The second kind is colloids. And this colloid solution, when it is obtained, these cannot be obtained in the crystalline form. They are in the powder form solution. The crystals cannot be obtained. And if you filter them, pass them through animal membrane, then they cannot be passed through it. Solution will not go across animal membrane. Everything will be retained above the membrane. Now, the other basis of classification is on the basis of the particle size. The substances which are soluble in a solvent form solution, they are classified on the basis of the size of the solute particle present in it. That is, first is true solution, second is colloidal solution, third is suspension. True solution, that is a homogeneous system. You know the meaning of homogeneous. Property will be the same throughout. And the diameter, this is an important point, diameter of dispersed particle. Dispersed particle means solute which are dissolved in the solvent. Dispersed particles less than 1 nanometer or 10 to the power minus 9 meter. You have to remember this figure, the size of the particle. And here, that is, they are either in the molecular state or in the ionic state. Molecules or ions, they are not visible even under the microscope. If you will see under the microscope, particles will not be visible, and then they pass through ordinary filter paper and also across animal membrane. So the solid particle cannot be retained even through the ordinary filter paper or through the animal membrane. The whole solution will pass across the ordinary filter paper and animal membrane. The two examples I have written, many more examples you can write yourself. Sodium chloride and sugar, ionic form and the molecular form. Now the second kind is colloidal solution. They are heterogeneous. Heterogeneous means property is not same throughout, and the size is important. That is between 1 nanometer to 1000 nanometer or 10 to the power minus 9 meter to 10 to the power minus 6 meter. So remember the range. They are not also visible, but under ultra microscope you can see them. Then they can pass through ordinary filter paper but not through animal membrane. So remember that. And the third kind is your suspension. System is heterogeneous here. Colloidal solution, example gum and gelatin. And suspension system is heterogeneous. Size of the particle is more than 1000 nanometer or greater than 10 to the power minus 6 meter. They are visible even through anodized and can pass through filter paper and animal membrane. So neither filter paper nor animal membrane can retain this suspension particles. So here only these many properties of these three solutions you have to do. There are many more properties given in a comparative way of these three, but those are not in your syllabus. Only these many properties you have to emphasize upon for your examination point. So colloidal solution, we'll do it today. We have seen just now, that is three kinds of solution. True solution, colloidal solution and suspension. Colloidal solution you have to do in detail. So colloidal solution has two phases. Since it is a solution, so solution you know is consists of solute and solvent. Solute is a substance that dissolves in a solvent. So here dispersed phase you can understand like solute, and dispersion medium you can understand like as solvent. So we will not use the word solute and solvent. Instead we will use the word dispersed phase and dispersion medium as far as it is concerned to colloidal solution. So dispersed phase is the phase that constitute colloidal particles, and dispersion medium is the medium in which dispersal or the colloidal particles are dispersed. Now colloidal solutions, that is colloidal system, colloidal solution which is also called sol, that is of two types. If we consider on the basis of dispersion medium, on the basis of the solvent which we are using. So as I told, we will not be saying the word solvent, we will be using word dispersion medium. So on the basis of dispersion medium, colloidal solutions are of two types, lyophilic and lyophobic. Lyophilic sols are your colloidal solution. So another name of colloidal solution is sol. So lyophilic sols or intrinsic property you have studied in detail in solution chapter already. Intrinsic sol, and these are also called reversible sol. And here we will see the property of lyophilic. Philic means loving, lyo is for liquid. So liquid loving, if they are loving the solvent, they are easily dissolved in the dispersion medium, then they are called lyophilic sols. If dispersion medium is water, solvent is water, then it is called hydrophilic. If your dispersion medium is benzene, then benzophilic. If dispersion medium is alcohol, then alcophilic. So normally hydrophilic is used, but when we talk in general a liquid, we call it lyophilic. And the most important property of lyophilic sol is that they are stable, self-stabilize, automatically themselves, they are stabilizing themselves. So they are stable, so they do not get precipitated. Once they have formed colloidal solution, their particles will not be growing bigger, and so they will not be forming precipitate of its own easily. Reversible means if you want to get back this dispersed phase out from dispersion medium, if you want to remove solute from the solvent, then that is possible. That's why this is also called reversible sol, and these are the other examples you can see from the book. Then the second kind is lyophobic. Lyo is liquid, phobic means heating. So liquid heating. So if it is water heating, hydrophobic, benzene heating, benzophobic, and so on. Lyophobic sols are also called extrinsic. Lyophilic intrinsic, so lyophobic are called extrinsic sols. Lyophilic sols are reversible, so lyophobic sols are irreversible. So other names of this also you can do. And then these were stable, but these are less stable. These were not able to precipitate easily, but they can be easily precipitated by any one of these three methods. Either you add some electrolyte, ionic compound in little amount, or you heat it, or you agitate it, shake it vigorously, then what will happen? It will easily be giving back precipitate, its colloidal phase will be lost, and what will happen, that is precipitate, but you cannot get back a dispersed phase from the dispersion medium. So irreversible, the process cannot be reversed. Example are gold sol, silver sol, and platinum sol. Now types of colloidal solution on the basis of size of the particles of dispersed phase. Solute particles, how much big are they on that basis? First is micromolecular. Micro means small, you know, also called multimolecular. So in that case, when either very small atom or molecules very small, how small? If the size is less than 1 nanometer, you know, colloidal particles must have size from 1 nanometer to 1000 nanometers. So If they have that much small size, then they are brought together, they combine together in the dispersion medium, in the solvent, when a small particle gather together and they form aggregate, bigger molecule having size in the colloidal. So small particles uniting together, forming little bigger particle, then it is the micromolecular. And these particles which are gathered together, they are gathered by means of van der Waals forces. Example, gold salt, sulfur salt, etc. The second kind is macromolecular. Macro means bigger. In that case, the molecules will not be that is small, like in this case less than 1 nanometer. They are bigger, but still not having the range of the colloidal solution, bigger than these particles, but they are not in the range of colloidal solution diameter size. And so when those are brought together and they are attaining size of the colloidal particle, then such type of salt is called macromolecular salt, and they have high molecular mass. So example, you can see that most of the lyophilic salts are examples: starch, protein, nucleic acid, polythene, synthetic rubber. You know, these all are polymers. So example of macromolecules are polymers. Then third kind is associated salts. These are also called micelles because these are normal strong electrolytes. When they are in little quantity, concentration is low. Dispersed phase is less than, very much less than dispersion medium. So if the concentration is low of dispersed phase and the dispersed phase is ionic, then they will be like your electrolytic solution, true solution. But if their concentration will be higher, dispersed phase will have little higher concentration, and then when concentration is higher, they are gathering together and attaining bigger size, and then they are called as a associated salt. Example, soaps and detergent. So low concentration, they are behaving like a strong electrolyte. Higher concentration, those electrolytes gather together and form bigger molecules. Such salts are called associated salts. Now we'll do preparation of lyophilic. So now we'll see about preparation of lyophilic salts. Lyophilic salts, you know that they are liquid loving, can easily be dispersed in dispersion medium. So they have strong affinity, strong attraction. Very easily they are attracted towards the solvent, that is dispersion medium, and so they can very easily be converted into salt, colloidal solution, by any one of these two ways. You mix them together, bringing them in contact, or just you warm dispersion medium with dispersion phase. So solute with solvent, if you warm, that is, then you will be getting salt. So preparation of lyophilic salt is not very difficult and is not very much time taking, but on the other hand, preparation of lyophobic salt, that is not that convenient like lyophilic salts, because lyophobic salts, they are liquidating, they disperse, phase is not attracted towards dispersion medium, and so they are not easily forming your salt. So therefore a special method has to be adopted. So two categories of method are there. One is dispersion method. Dispersion method means bigger particles. You know that colloidal salts have a particle range between 1 nanometer to 1000 nanometer. So if the particles of the dispersion phase, that is solute, the substance of which you have to make colloid, those particles are quite bigger than 1000 nanometer, then they are dispersed, means they are crushed, broken and brought down into the smaller particle in the range of 1 nanometer to 1000 nanometer, and thus they are turned. So three methods you will have to study for as a dispersion method. when from the bigger particles, the small particles are being made. The second method is condensation method, when the dispersion phase, that solute particle of which you have to make colloid, the size of that is smaller than 1 nanometer, and so you have to grow the size of it so it becomes bigger and fall into the range of 1 nanometer to 1000 nanometer, and so aggregation, collection, gathering, accumulation will be there, and such method is called condensation method. So in this you have to study two methods, chemical method and physical method. So we will see now. Okay, now dispersion method, as I told that that is your bigger particles, the size will be more than 1000. You know, this is the range of the particle of a colloidal solution. So if the size of the particle is greater than 1000 nm, then dispersion method is used. And the first is your colloidal mechanical method of dispersion. So for that, what is done? That is two heavy mills disc. Two heavy discs are used, which are fixed at the top of the other by means of the axle, and this disc rotates. That is, this is rotating both of them, but in the opposite direction. If one is clockwise, then the other is in anti-clockwise. And from here is the opening, just like your the mill of which you must have seen that wheat is ground. So from here, that is from here your cores, that a bigger particle of the solution suspensions have bigger particle than 1000, so that goes from there, that is poured, and this is passed through this and comes in between these two. So this gap is adjusted according to the size required, between 1 to 1000 nanometer. So the distance is increased or decreased accordingly, and the course of suspension is passed from there. And these two discs, they rotate in opposite direction, and the revolution is 8000 rpm, 8000 revolutions per minute. So that fast it moves, and then when it is crushing, so this coarse particles of suspension come over here, and they are dispersed, spread, and from here comes out your colloidal solution of the desired particles of the dispersed phase. So this way the first method is used, and in that we are also using a diluent. Diluent is added so that whatever the size is required according to that calculated amount of the chemical substance, diluent is a chemical substance that is added, so that the size of the colloidal particle will not grow bigger than what is required. So that is all calculated amount, required site amount. For example, glucose, calculated amount is added in sulfur salt, and so if this is added, then we get the desired size of the particles of the sulfur salt. Now peptidization, in this peptidization, that is precipitation is caused, and so for that if you have to prepare salt of ferric hydroxide, then you will prepare fresh precipitate of this ferric hydroxide, and then since it is in the precipitate form, bigger size of the particle, so if you have to convert this into the smaller particle in the colloidal solution, you will add little amount of ferric chloride. This ferric chloride, little amount which you will be adding, this is electrolyte, and this will be called peptiding agent. So FeCl3 in FeOH is peptiding agent. So what does it do? It helps to disperse this precipitate into the desired size what is required. And so here this is peptiding agent. Similarly, a silver nitrate is peptiding agent, and that is used to disperse silver iodide precipitate to get silver iodide sol. And this phenomena in which the precipitate of a substance is turned into the colloidal form, that is called peptidization. So that is your second method. Third method is Briggs arc method, that is electrical method. In this your metal that we prepare salts of metals like gold, silver, platinum, noble metal, their salts are prepared. So that is how that is. Two electrodes are used. If you have to prepare salt of gold, you will use electrode of gold and you will take suitable dispersion medium. The gold will be your disperser phase, and this you will be keeping in the disperser medium. This is kept in the freezing mixture. So here is all your freezing mixture, and high voltage current is passed, and these two electrodes are made to touch with each other. When they touch, then the sparking is taking place, and the metal, when they touch, then from the tip metal is attaining very high temperature and is turned into its vapor form. So vapors of that metal is formed, but that remains in your, this is your dispersion medium in which this rod is dipped, and the spark is obtained in the dispersion medium. So those small particles which are there, they are formed in a dispersion medium, and since that is kept in the freezing mixture, so it get cooled and get deposited here in the smaller particle, and so that remains in the dispersion medium. So this way we are getting your colloidal solution by electrical process. Now the second method, condensation method, when the smaller particles they are made to grow bigger. That is first method is chemical method. Then chemical reactions are taking place in that the particle size of the dispersion phase is very small. You can see that maybe atomic size or ionic size. And so the first method which is used is for oxidation. Example, you have to remember at the process that sulfur salts are prepared from these two gases. H2S is gas, sulfur dioxide is the gas, and these are taken, but this is taken in the aqueous form. So sulfur dioxide is dissolved in H2S, and then your sulfur salt is formed. And another example, you can see H2S aqueous solution is taken, in that oxidizing agent bromine is added. Your oxidizing agent is sulfur dioxide. Your oxidizing agent is bromine water. Br2 over H2O means bromine water. Or in place of bromine water, you can use sulfur dioxide as oxidizing agent, or you can use nitric acid as oxidizing agent, and then we get sol of sulfur. The second method is reduction method. In that we are preparing salts of these noble metals, silver, gold, silver or platinum. For that we are using salts of these metals, of which you have to make the salt. So salt you will use of these, and very dilute solution you will use in the reaction. So if you have to make of gold, the salt you will use auric chloride, and very dilute solution of auric chloride you will use. In that you will add stannous chloride as a reducing agent. Then the sol of this will be obtained. This is reducing agent, so this will be reduced. Chlorine will be out, taken up by this, and so auric chloride will be converted into auric sol. Third method is double decomposition. And then this is the two salt, these are there. Salt of arsenious sulfide, this is arsenious oxide. Dilute solution of this is used, and we add to this H2S, then we get exchange is there, or H2O, and is 2S3 is formed arsenious sulfide. So simple reactions you have to remember and identify. Through the reaction what is oxidized or reduced, you can use oxidation number method also to find out which substance is oxidized and reduced, and then you can decide. Then second method is your physical method. These three methods were chemical method where chemical reaction was taking place. Another method is physical method where no chemical reaction takes place, and that method is also called exchange of solvent. So example is salt of sulfur. So sulfur salt which is prepared in alcohol, and then in that we add a second solvent, water. So true solution of any substance is used, and in that we are adding solvent, another solvent. Suppose so this true solution is what you have solute dissolved in a solvent. So let this solvent be one which is present in the true solution. So the solvent 2 which we will be choosing, what will be the nature of this? That the solute particle should not be, the solute should not be soluble in solvent 2, but solvent 1 must be soluble in solvent 2. Okay. So what will happen, that is when this is solvent 2 which is mixed, the solute is not mixed, then exchange of the solvent is taking place and the solution which is obtained, that is salt. So remember here that is solute of the true solution is not soluble in solvent 2 which is added. So this way we are preparing, so if you have to prepare salt of sulfur, you will use solution of sulfur, sulfur dissolved in alcohol, that will be the true solution of sulfur in alcohol, and sulfur is not soluble in water, so you will add the second solvent as water, and then what will happen? You will obtain the salt of salt. How salts are prepared by different methods. Now we'll see that purification of the salts. So colloidal salt solution which have been prepared by various methods which you have seen in the previous class. They contain a number of impurities, and those impurities are because of the electrolyte. As you have seen here, that electrolyte, when we add a little amount, it will stabilize the salt will retain its characteristic. But if these electrolytes will be in large quantity, it will destabilize the salt. So if they are in large quantity, we have to remove it from the salt so that salt can be permanently stored and it will remain in the salt condition permanently. So first method is dialysis. As you know that salts, they are retained by animal membrane, across animal membrane. These salts, colloidal solution cannot pass through, and so therefore salt is made to pass. Actually salt is made to pass through animal membrane, and then this animal membrane which is there, that will remove all the impurity from the salt. And so this property of animal membrane that retains your salt particle but allows that your impurities to move out, that process is called dialysis. And so in the dialysis process, a bag is used that is made up of a suitable membrane, and that membrane I have written, for example, parchment membrane, sulfate membrane or animal membrane, and in this your impure salt is filled, and outside is your suitable solvent is taken, and then from here all electrolyte which is undesired, that will be passing out, but salt particle will remain inside, and so the phenomena of dialysis will be taking place. So this way they are made to purify. Now the second method of purification is ultrafiltration. For this special filter paper called ultrafilter is used, and that is prepared from ordinary filter paper. But ordinary filter paper cannot be used directly, because the pore of, if this is your filter paper, then the pores of these are quite big. If I show you like this, so these pores are very big, and that will not retain the particle, that will not stop or will not remove neither your electrolyte particle nor colloidal. So both true solution particle and the electrolyte particle, that you can say, and the colloidal particle both will be passing across this, so filtration is not possible. So if this, I take that is, this is suppose the size of the pore of the filter paper. If the size is reduced, if this is reduced very small, and then what is there, it is able to retain. And so this size of the ordinary filter paper is reduced to very small one. That is by dipping this, I have written down here that ordinary filter paper is taken and dipped first in colloidal or in gelatin solution, and then when it is dipped, then this is absorbing that on the surface, absorbing these particles of colloidal or gelatin, and then this is dipped in formalin. So formalin will harden it. Again it is dipped in this and dipped in formalin. So this way gradually depositing, and the size becomes very narrow, and that narrow sized this filter paper which is obtained, that is called ultra filter paper. And so that ultra filter paper is used, and across this, when the impure sol is passed, then the filtration can take place, impurity will be filtered out, and the sol will be retained on the filter paper. Next method is ultracentrifugation. For this, we are using this process for the purification of protein sol. Impure sol is rotated in a special apparatus called centrifuge. In that, with a high speed, this your sol which is impure is rotated with, and so what happens that the sol particles, they are settling down, and so this process is called ultra centrifugation. Now properties of sol.